Okay, hi everybody. Any questions before I start? Okay, so today we're going to talk about coroutines. The first thing I want to talk about is to find the actual dependency that you need to add to your build. I always just search for Kotlin coroutines dependency, and it's this GitHub link. You'd think by now I'd remember the link for it, but let me invite somebody else. But this is the link you're going to want, the one that's on GitHub. And when we go there, I can kill that annotation. On here, if you just scroll down, you're going to see a little section where it talks about Gradle and how you're going to set up the dependencies. There's an extra library that you need to add to use the coroutine support in Kotlin. So what we're going to do is I just copy this guy, and then we can come over to our build.gradle.kts. Just going to paste it in. Now it's okay to have multiple dependencies blocks. It'll actually add things in there. I just prefer having one. So I'm going to go ahead and delete a couple lines there. Also note that the one that it copied is a beta version. So I'm just going to back that off to be 1.8.0. And now we have the dependency added in. Notice that this little guy up here shows up. This is letting me resynchronize the Gradle changes with IntelliJ to make sure that it understands that these libraries are available for content assist when you're working in the editor. So I'm going to go ahead and hit that. That should be good. And now when we go into here, I should be able to use some of the support. And just to test it out, I'm going to say val scope equals coroutine scope, and there it's actually there. Now that's not actually the right syntax for it, but I just wanted to test that that is actually importable. And you'll see that it's coming from Kotlin X coroutines coroutine scope. Kotlin X are extension libraries that are provided by JetBrains for Kotlin. So I'm going to go ahead and delete that, and we're good there. So that's the first thing you're going to want to do when you're dealing with coroutines. Make sure you add in that dependency there. Now this is an implementation dependency, meaning that you'll have it in any of your source code. So when we go to source main Kotlin, any of the code there will have access to that at compile time and at runtime. That'll be pulled into the runtime dependency. When he says test implementation here, these are only available to things underneath source test Kotlin. So those won't actually be included in your runtime libraries if you're delivering an application, for example. Okay, any questions about that? Cool. Well, let's start out with a problem case here, just to kind of get a feeling for what we're trying to tackle here. So to start with, I'm going to create a simple little UI using Java Swing. And these are the components that come with the Java virtual machine. So you won't be able to run this if you're using Kotlin multi-platform to create JavaScript or Android or something like that. This will only work on desktop running underneath the Java virtual machine. So I'm going to start off by saying JFrame. We're going to create an instance of him, and then I'll initialize him using apply. So inside of there, I'm going to set his layout to be a flow layout, just kind of like that. And then I'm going to just create a couple little pieces here to set inside of this layout here. So we're going to say, give me a label. That's going to be a JLabel. And I'm going to put nothing there as far as the text to start with. This is going to be some text that I want to update depending on how the buttons in the user interface work. So we'll come down here. I'm going to say, give me a button. He's going to be a JButton. And I'm just going to have him have text, press me, something like that. Now let's initialize him as well. And I'm just going to initialize him to add an action listener. And this is using the observer pattern to attach a listener lambda to this button. Now, actually, what's happening behind the scenes is add action listener takes an instance of an interface called action listener. And action listener is a SAM interface. That's a single abstract method interface. So we can reference it as a Lambda, and it'll create an instance of that interface, filling in the details of on action performed for using this Lambda that we have defined here. So what I'm going to do is with this button is I'm going to say when you push the button, I want to display the numbers 1 through 100 on the button itself. So what I'm going to do, or on the text field. So I'm going to start off with a range. So we'll say 1 to 100, and I'm just going to loop through it for each. And then in here, I'll just say label.text equals it.toString. So that'll just take this number that it cycles through on this for each and print out the toString. Now I could also, instead of using 1 to 100, I could use repeat, and that will walk through 0 to 99 if I say repeat 100. But what I also want to do here is let me throw in a little bit of a delay so that every time this number appears, we can actually see it. So I'm going to say thread.sleep 20. So I'm just going to sleep 20 milliseconds. It should spin through these pretty fast. So now what I need to do is add this button and this label to the layout. So I'm going to say add button and add label to the layout. And I'm actually looking at my wrong example here. I wanted a border layout. I was looking at my old example. Let me look at the new one. That's what happens when you have too many windows open. So we create our JLabel. We have our button. And let's see that button. So I have him doing that 1 to 100, setting it, sleeping 20. That looks pretty good. And we have our add button, add label. Let me add one more button here. Button 2 equals JButton. Add an action listener to him. And what this button's going to do, let's give him a little text on here. Press me to. So this guy, all he's going to do is change his own label. So every time you press him, he's going to add a little number on it. So inside here, I'm going to have a little variable. And then, oops, I'll put him up there. And then whenever that action listener is pressed, I'm going to increment that variable and then say text equals pressed $n. So we should be able to press that multiple times and actually see it increment. Okay, so these buttons, what I'm going to do is I have the border layout. So let me add this as border layout dot north will be the first button, and south will be the second button. And then let's just add the text to the center, kind of like that. So now we got our basic user interface set up. I just have to add a couple extra things here to handle what to do when you try to close the window, setting the size and making it visible. So I'm going to say default close operation equals window constants. Oh, and just a little heads up, I'm not going to have anything on swing in the exam. This is just an example of a type of user interface. This is not a user interface class by any means. I'm just using this as a little example to kind of show you how things might look or work. So do exit on closed. I'm going to set my size, and let's say 400 by 200 sounds pretty good. And then we're going to say make it visible. Okay, so here we have a fairly simple little user interface. And let's try running this, see if it actually works. And I'll pull the user interface over here. You can see it. So here's our little user interface. Can everybody see that okay? Just make sure I have my screen set up right so you can see the user interface. Excellent, thank you. So inside here, if I do the press me to, you're seeing that it's doing that pressed with the numbers on it. That all looks great. Let's go ahead and hit press me 1. Kind of hung, and then we see 100. We didn't see any of the numbers in the middle. Let's try one other thing. When I press it, note that this button down here isn't reacting, but then it updates and catches up. So I'm going to press the top one, and I'm going to press this bottom one. I'm clicking on it several times right now, and you'll see that it actually jumped forward. So what's going on here? The problem that we have, and let me bring him back up here. The problem that we're getting is that the user interface has a single thread to do its drawing and to react to user interaction. So when the user clicks on this button down here, that's triggering this action listener that we added, incrementing and updating the text on the screen, and then it's done. This doesn't take very long. So it keeps feeling interactive to the user. But if we look at this other action listener that we added up here, this one's a whole lot of trouble. This one's cycling through 1 to 100 and doing a sleep of 20 milliseconds each time. This is running on the user interface thread. That's the same thread that handles any other clicks from the user, as well as updating the user interface. So because this is busy, the user interface can't be redrawn to change that text on the screen. That's a big problem. So this is causing, first of all, the text isn't showing up, and second, the user can't interact. All those clicks queue up. So you end up with an interface that feels janky. It kind of hangs when things are happening. The user can't interact with it as smoothly. So that's why when we press this guy, notice how the button stays down until the 1 to 100 is done. And this one over here, as I'm clicking on it, doesn't go down until the end and then suddenly updates to the final number. So that's not good. So what we'd like to do is change this so that when we run it, this doesn't block the user interface thread. And so what we're going to do here is use multitasking. Yay! We're going to set up a separate thread to run this action and do the updates. And when that action is running, it's changing the data on the label. The user interface thread says, oh, hey, I can repaint it on the screen now. So to do that, I can just come up here and say thread. And now note, from Kotlin, you really don't want to do this. We're going to use coroutines in a little bit. But just to kind of show you what's going on, we can say thread. Now, what this is doing is it creates a runnable. So this block here implements runnable, which just has a single function called run. The lambda here becomes that run function. We're passing that to the thread so that the thread knows what it has to run. But just doing this, all it's doing is creating that thread object. It's not actually executing it. Now you have to be really careful here, because if I say thread.run, that might sound reasonable, but what that's doing is that's just calling this runnable and not actually starting a new thread. So thread.run doesn't do anything. And you'll notice here the little warning that it gives us, calls to run should probably be replaced with start. So the difference is the thread has that run function, which is what it's going to do. Start actually creates the thread instance and runs it. So it actually launches it as a separate parallel thread and then calls that run function that we've defined here. So now if I run this, we should see some better results. We'll bring him back in here. First of all, this guy's still working. That's great. I can press this. Notice that it responded, and now my number is updating. While that's going on, I can also press this at the same time, because now they're running in separate threads. We're not blocking the user interface thread again. So that's some of our motivation here. Multi-threading can be really super useful in an application, especially a user interface application, where in a lot of different user interface toolkits, like Swing and like on Android, the main thread is the thing that's updating the user interface. You don't want to block that, or it won't be able to update that interface. Any questions on that? Does that make some sense? Sure. Well, this is a Java-like practice. So we're actually using the threading library in Java, which is pretty heavyweight. Creating a brand new instance of a thread is very, very heavyweight, and it's a limited resource on the system. So you really don't want to create multiple threads to do things. If I press this button multiple times, it's going to create a whole bunch of threads. Coroutines are much, much lighter. We'll talk about that in a minute. One other problem with the way this is designed, because I'm launching a thread, if I click this button multiple times, it's going to do some pretty funky stuff. So if I run this, we can come over here, and when I press it multiple times, notice how the number's all over the place. That's because multiple threads are updating that user interface element. Now they all end at 100, so that's fine. But as it's going, we're no longer getting that progression. And if I put a little bit more delay in there, you can actually see that a little bit better, how there's multiple threads. So if I click it, you notice how it's kind of jumping between them. And then we got the one. And yes, question or? Yeah, sure. Now, just as a little note here, while we're looking at this, any ideas on what we should do here to prevent this from being a problem like this? Any thoughts? Exactly. So it's not the thread we're going to lock, but inside of here, we could disable the button until the thread's done running and then re-enable it. So we might do something like this, is enabled equals false. And we really want to do this in a try finally to make sure that we're going to be okay. And then is enabled equals true. The try finally makes sure that if anything goes wrong inside of here, I'm always going to re-enable. If I just put the is enabled false and is enabled true there, if something went wrong between them, the button would never be re-enabled. So this is one approach we can do. We can just say, hey, when you click it, immediately set is enabled false so they can't click it again. Now there is a little gap in here, so we have to be kind of careful on how we approach this. We might want to put the try catch or put the is enabled false outside at the top level of this add action listener. So this is one approach, and we'll just kind of see how this looks. And let me grab him. So when I click it, notice how it went gray while it's running and I can't push it again. Oops, I have it slow again. Let me speed it back up. So I can't click on him anymore. And then he comes back at 100. I can click on him again. If I click on him a little too fast, it's possible that we might get two threads going. Apparently my finger is not that fast right now, but there is a little bit of a gap. Think about that as well. Now another approach is something called debouncing the button. And what that means is that when you click the button, instead of immediately starting this task, what you end up doing is you start up a thread that waits for maybe 50 milliseconds. And if that 50 milliseconds has passed, you do the thing that you're trying to do. At the start of that, you cancel any existing threads so that if you have already clicked the button, the first thing you do in there is cancel that thread and then start a new thread that waits for 50 milliseconds first, then does its job. So the idea there is to try to set it up so that if the user clicks multiple times, it's only the last click that counts. Okay, any questions on that? Okay, so now let's take a look at a kind of a little approach that you might end up doing in Java. There's a bunch of ways to do multi-threading in Java, but sometimes you'll find a library that builds in the multitasking for you. And all you need to do is set it up so that you call a function and pass in a callback to say what to do when the thread is done. What do I want to do with the result of it? And that might look something like, let's actually create a Java directory here. And inside of there, create a package. I'll say week 11.01. Just call it Java stuff. There we go. Just to not confuse it with anything else. And so inside of here, let's create some Java stuff here. I'm going to create a class I'm going to call Actor Finder. And what I'm going to do in my actor finder is set up kind of a little simulation of fetching actors, and then for each of those actors, fetching movies they're in, and then for each of those movies, fetching the theaters that are showing them, just to kind of show how some of this might work. To do that, we're going to need some classes. So I'm going to say class actor, movie, and theater. And I always, when it's a movie theater, I always use ER. When it's a proper theater showing musicals and fun stuff and stage plays and things, I use RE. That's just my definition of it, just to be snooty about it, because musicals are awesome. Hopefully everybody else here loves musicals. They're fantastic. So let's add in a little class here. I'm going to call, actually I want an interface, result. And he's going to be a generic interface that's just going to pass you in whatever result you're expecting. So I'm going to have two functions in there, on success, and he's going to return a list of results. And then on failure, and I'm not going to have any function there. I'm not really going to go into the details on failure. I just want to show you a difference in how you might do it here versus how you might do it in coroutines. So now we have that all set up. And in our actor finder, what I'd really like to do is just copy this little comment, fetch a list of actors from somewhere. I'm going to assume it's a web service probably. And then for each of those actors, fetch movies that have those actors. And then for each of those movies, fetch which theaters are currently showing them. So it's going to be 3 sets of web services call. One web service call to get all the actors. And then for each actor, one web service call to get the movies. And then for each movie, one web service call to get them. So you can imagine this would be a lot of activity going across the network here. And trying to parallelize this would be really nice. So we're going to start off with a little function here to fetch the actors. And he's going to take in a result class. Actually, let me rename that to be result handler. Something like that. So he's going to take in a result actor. And that's going to be the callback. So fetch actors is going to kick off a thread in the background and immediately return. He's not going to wait. We pass in an object that says how to handle the result coming back. And then that object is going to further call other functions here. So inside here, so say start thread to fetch all actors. And I'm just going to, pretend. And then inside here, I'm going to say list actors, equals new array list. So I'm just going to pretend that I'm actually fetching something here. And then we'll say result dot on success. And if there was a failure, we'd obviously call result on failure. Okay, so that's our fetch actors. And now I'll just add in another one here saying fetch movie for actor, which is going to pass in an actor and a result that gives us a list of movies. And so this here I'm going to say movie, movies, kind of like that. So that's our fetch movies for actors. And then let's do the same kind of thing for fetch theaters for movies. So we're going to say movie, and that's going to return theaters, and then this is going to return theaters, showing a movie. This is going to fetch movies starring an actor. something kind of like that. Okay, so there's three little functions that I have there. And let's see what happens if we try to use this. So I'm going to come into here and I'm going to add in a new Java class. Let's call it example. And inside here, let's throw in the main functions. This is what we're going to run to actually test things. Now, I'm not going to actually run this one because it really doesn't do anything, but I just want to show you what the code would look like here. And this is where things get fun. So inside of here, I need to create an actor finder. Boy, it feels weird to type new and type semicolons. And so inside here, I'm going to say actor finder.fetch actors, and I want to pass in a new result handler. So when I create that, it's popping in these two functions. He's created an anonymous inner class. That's when I say new interface, it creates an anonymous inner class with those two functions. Now you'll see that actor here isn't necessary because Kotlin can infer it, or Java in this case, can infer it based on the fetch actors function, who's expecting actors. So I could remove that. That's perfectly fine. I still need it here to say I have a list of actors in my results. So now what I'm going to do is, okay, inside this success function, I have a list of actors. Great. So now let's say actor finder dot fetch movies for actor, passing in each of the actors. Well, we're going to have to walk through those. So we'll say results dot for each actor, something kind of like that. And then in here, to fetch them, I'm going to pass in that actor and new result handler. He pops him in there. And I can get rid of that movie because he already has it. So inside here, I'm going to say results dot for each. It might help if I could actually spell. There we go. And then he's going to take a movie. And boy, Kotlin lambdas are so much cleaner than this. This is just gross. And so then inside here, I'm going to say actor finder dot fetch theaters for movie, passing in the movie, and new result handler. And then down inside here, print out the theaters. Now this is what we call callback hell. And let me just put a little note in here. And this is callback hell. And this is very, very typical when you have some functions that can do things in the background. Because you either have to wait for the function to return or kick it off and then have it return the values to you via a callback or something like that. Now, there's other ways to deal with values. You could use something like an event bus. You could use other ways of sharing the data between the different threads. But this you're going to see quite a bit. And this is super gross. It gets really, really hard to follow what's going on here. So we want to try not to do this. So let's come into here and take a look at how we might do this in Kotlin. Now, again, I'm not going to fill in the details in this example, just going to kind of go through showing you some of the pieces here. So we're going to start off by saying I have a class actor, and then movie, and then theater. God, I love Kotlin. And then let's create some functions here. So I'm going to say fun, fetch actors, and he's going to return a list of actor. And let's just say return list of. So to start with, I'm just going to treat this as synchronous functions. So just very simple functions. We're going to assume this goes off, grabs the data, but we're going to have to wait for every single one. So we're not going to have any parallelism to start with. But we'll come back to it. And so then in here, I'm going to say fetch movies for actor. And it's going to be list of movies. And then fetch theaters for movie. Okay, so far so good. Now, if we were doing this synchronously, inside of our main here, we'd basically be saying, okay, let's do a val actors equals fetch actors, and then actors dot for each, and then we'll say val movies equals fetch movies for actor, and then movies for each, and then we're going to get the theaters. Whoops. Fetch theaters for movie, and then do something there. So this is if we were doing this synchronously. And, that's pretty simple. But of course, it doesn't help us, asynchronously, right? So let's take all of this. I'm going to go to my next one here. And let's change that to 3. So we still have our actors and everything. Let me make a few tweaks here. And then I'll explain what all this does. And let's see, I didn't want anything else there. And then down here, I need to tweak a couple things. Okay, let's see what else I want to do in here. Oops, need to import him. And let's see, we'll do kind of similar in here. And did I want to do that again for the, yeah, I want to do it for this guy as well. And poof, I didn't change a whole lot here. And you can see the structure looks very, very similar to what we were doing synchronously. But now what we're doing here is at the start, we're launching a background process here. I'm just going to call it that for a minute. It's called a coroutine. We're launching a background process to run all the work inside of this Lambda. And then for each actor, we're launching a separate background process here. So it's going to be a separate coroutine for each actor to go and fetch the movies for that actor. And then for each movie, we're going to launch the fetch theaters for movies. So we're launching a lot of background work here. But this background work is incredibly efficient. We're not actually launching heavyweight threads here. We're launching something called a coroutine. And this guy up here, dispatchers.io, is basically a thread pool. He's going to manage the threads that run things. And all of these wonderful little coroutines are going to be managed by him. So we're going to take advantage of however many threads that dispatchers.io defines to go and do all this fetching concurrently. This is a super nice way to write this because it looks like what you think it should look like. It doesn't have all that callback hell. It doesn't have a whole bunch of extra data being passed around through those callbacks. It just looks like straightforward code, but this is all happening in a bunch of different subroutines or coroutines. If you thought about, let's say that we have two actors and there's two movies for each of those actors and there's two theaters for each of those ones, that's going to be 2 cubed, what is that, 8 of coroutines running at the same time to do this work for us. Well, they're not all running at the same time. We still have to first run this first one here to fetch the actors. Now what we're doing here is these coroutines are being launched in 2 ways. There's this guy here, which just says launch something that's going to do some work. I don't have any value coming back, so I don't care. But async says launch something that's going to return something. So this async with the lambda, which is the work that's going to perform, returns something that's going to wait for us, or we can wait on. That's called a deferred. So if I float over async here, we'll see, well, you can hardly see that in there. It's all, you can see he returns deferred. And the deferred has this await function here. So you can kick off that and somewhere later on await. Now, a lot of times you're going to see async and await chained together exactly like this, but you don't have to do that. You could actually say async blah, 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 return that deferred and use it someplace else, and maybe have a bunch of awaits that are pulling together. So all I wanted to do right here was just kind of give you a taste of what this might look like. Let's do a look at these functions that I tweaked up here. So fetch actors, fetch movie for actor, and fetch theaters for actor. They look really, really similar to what I defined before, but there's a couple really nice things added in here. I added this suspend keyword, and I added this with context function. So first of all, let me talk about with context just a little bit. With context is giving us an ability to switch a coroutine context that we're going to run on. So in this case, we're running on the coroutine context that uses dispatchers.io. So dispatchers.io is optimized for blocking IO functionality. So if we're going across a network or if we're writing files, dispatchers.io is efficient for that. Suspend is a keyword that the Kotlin compiler uses to do some really, really nice magic, but it's not magic at all. What that says is this said that this function is called a suspending function. Surprise, surprise. And what a suspending function does is a few things. He can contain calls to other suspending functions, and we'll see how that breaks down a little bit later. But he also is a place where anytime you call a suspending function, like down here, we're calling fetch actors or fetch movies for actors or fetch this guy, anytime you call those functions, it gives Kotlin a chance to suspend the current coroutine and let somebody else take advantage of the processing. Now, what does that mean? There are really kind of 2 general types of background processing. There's one called preemptive threads. Whoops. And there's another one called cooperative. And cooperative is the older of the 2. And what cooperative processing means is that each application must share the processing explicitly. And this was a pretty early way of doing things. Basically, when your application starts running, it's up to you as a good application writer to yield that functionality, yield the processing at certain points in your code. So you'll do a little processing and yield. The computer then says, oh, okay, he yielded. Let me pull somebody else in to use that background resource or that background thread. And Maybe the CPU only has one thread that he can run. If your application doesn't yield, nobody else can get any processing done. They starve. So must yield explicitly to allow other apps to share the processor. Now, preemptive was mainly created because not all applications played fair. And it's also having the explicit yield was pretty easy to forget. I mean, you don't necessarily have to be an evil citizen. You could just be, maybe you forgot, maybe you had a bunch of processing happening and you're not yielding for other applications. So preemptive, the computer time slices. And what he'll do is he'll swap app and data in and out automatically. So in a preemptive system, you don't have to worry in your code about multitasking at the computer level. It happens automatically. So if your processor has 32, let's say your chip has 32 processors on it, and maybe each processor can handle 4 threads. Each of those threads can be shared with different applications. And if you have more than that applications or background processes running, like, if you look at the typical process list on a computer, there's a ton of stuff running in the background. A lot of system services, a lot of applications, depending on what you're running there. So you could use up those resources pretty quickly. But the computer will then take your code, your application code, in and out of memory as needed. He will have the processor pull data in from your specific set of data on the processor. And if it needs room, it'll swap that out to disk. This can be very expensive if you have more things running than you have physical resources, or if you don't have enough memory to have everything kept in memory at the same time, even though they're not all running at the same time. But this made it so that you really don't have to worry as much. This can be slower. Because you're using full-on thread resources on your system to do the actual work. With cooperative early on, you were using full resources, but then some libraries started coming into the picture. You can kind of think of them as lightweight threads. Did I hear somebody starting to ask a question? Or that was somebody's head spinning. That's okay. So coroutines, if I could spell it right, are kind of like lightweight threads. And these, actually, let me do this. So they're kind of like lightweight threads, and they're cooperative. So you need to yield. But Kotlin makes this easy. Every time every time a suspend function is called, an angel gets its wings. Now, every time a suspend function is called, the coroutines are yielded. And there are the coroutine, I should say. Coroutine yields automatically. And there's several functions that you might call, like if you have a delay function that pauses or slows things down in the middle, that's a suspend function. And so what the coroutine manager will do is switch from your coroutine that's running to somebody else's on whatever dispatcher you were using, and basically just shares it. And because you're going to call suspend functions fairly often, this works out pretty well. Now you can explicitly call yield. Yield is just a really simple suspend function that is you saying explicitly, hey, I've been doing a lot of work, let me break, because maybe you're doing a lot of work in a row that doesn't call any suspend function, and maybe you realize, hey, I should be a good citizen and pause at this point, let somebody else have some processing. And that somebody else could be you. The whole idea with coroutines is that you can use multi-threading to a much greater extent than you could with just using native threads. So that's the basic concept that we're working here. And let's take a look at what a coroutine does kind of behind the scenes. So let's say that we have some suspend functions. I'm going to call A and then B and then C. So there's 3 suspend functions. Let me throw some normal functions in here. So I'm going to say fun X, Y, and Z. And then let's have some caller. So I'm going to say fun caller. Maybe he takes a parameter. And inside of there, I'm going to call X, Y, A, Z, B, C, something like that. Now notice there's some errors there. And also notice these little icons on the side. These icons are telling you I'm calling a suspend function at this point. But notice how those are marked as errors. This guy is going to tell me that I can only call a suspend function when I'm inside another suspend function. So what that means is I have to come up here and add suspend to my function. And this is one of the things that helps drive this automatic yielding. Anytime you call a suspend function, whether it's delay, with context, or one that you've defined, you have to make the caller be a suspend function. So it kind of percolates up. And this, in turn, when somebody calls caller, that's going to cause that break there as well. Now let's say that this guy, maybe he returns an int. We'll just return some value there. So that's what the caller looks like. Now, what I'm going to do is I'm just going to copy a block of comments that I created here. The Kotlin compiler uses this function to change your code somewhat. And so what we'll see here, and this is kind of a rough approximation of what the code change looks like, just to kind of give you an idea. But basically what it does, it looks at where the suspend functions are called, and then chops your function up into pieces based on that. So if I see if this is going to work. Come on up here. There we go. So if we look at this, we have a call to a suspend function B there. We have a call, or A, then it's a call to B, and then a call to C. It basically is chopping this function up into 3 parts. I'm sorry, I did this the wrong way. It's before the suspend function is called where it breaks. So it breaks this up into 3 parts. I'm going to call this 1, 2, 3, and 4. Wow, that worked really well, didn't it? Okay, it's not 9, 4. There, close enough. So I'm breaking it up into 4 pieces here. And I'm using a new graphics tablet I got, and it's a little getting used to it. So I've now broken that up into 4 parts. And what the compiler does is he essentially puts those 4 parts into a big when expression. So if we take a look down here, whoops, kind of left that stuff. Let's kill that. There we go. If we come down here, this is kind of what this function looks like. So we have this when with 4 chunks, and the code's put in those chunks. But you also notice there's a new parameter added behind the scenes. This parameter is called a continuation, and he'll do things like keep track of data that's needed in each of these chunks, as well as keep track of which chunk to run. So when you first call it, it's going to say run the first chunk. And the first chunk is going to say, okay, let me load any data that's in the continuation. Let me call the stuff before that first line, so up until that suspend function that we called. After those are called, take a look at any data that I have, any type of local data, store it, and then set the continuation to go to that next chunk the next time it's called. Now, when the coroutine handler calls all of this, he's basically going to run this, and it's going to run to this point. It'll return to the coroutine manager, and the coroutine manager is going to say, okay, I'm done running that. Let somebody else have a chance. So notice how that matches up with this suspend function being called here. So somebody else might have a chance, or if nobody else is waiting, he'll run again. And so what he'll do is he'll then take make a call to this guy, passing in that continuation, which now says run block 2, and he runs that block. Once again, when it returns back to the coroutine manager, he's going to say, okay, it's suspend time. Does anybody else need to run? Then he reschedules this for block 3 to run. Block 3 runs. At the end of that, the coroutine manager says, okay, let me go ahead and break, see if anybody else, I should say suspend, not break. Let me go ahead and suspend, see if anybody else wants to use this, and then comes back and runs this again, passing in the continuation with that 4. So pretty simple there, right? Let me actually change that. I called it label before. And this actually isn't exactly how this works, but conceptually, this is really what's going on. Okay, so this allows us to run chunks of this function up to a certain point, and then actually break and let somebody else run. So it returns to the caller, who is the coroutine manager. Does that make some sense? This is one of those things that when I first started learning about coroutines, it was really puzzling to me because it felt like magic. How do we stop running at this point after we've executed these? How do we break and let somebody else run? And it's like the compiler is using that suspend keyword to do some modifications to this function. So pretty cool stuff. Okay, so let's take a look at doing something a little more interesting. So let's say that we were doing a real application here. And what we want to do in this application is have kind of a few different layers. We want to have a data layer that's going to manage whatever data we have. So in this case, it's going to be a list of movies. We're going to have a view model, which is in our user interface layer, which is going to communicate with the data layer to get data, and then a user interface that's going to display that data for us. And we'd like to try to approach this as cleanly as possible. We don't want to have explicit notification of something's changed. We'd like to take advantage of coroutines to do some of that work for us. But to start with, let's be a little bit explicit on this. Let's have the view model do the thinking as far as doing updates. See if we can get this to work. So I'm going to start with a data class called movie. And he's going to have a little bit of information in here. So I'm going to say val ID. It's going to be a string. And val title is going to be a string. And val year is going to be an int. So we have that data. Pretty decent start there. Let's create a data layer component here. I'm going to call it DAO. So it's going to be movie data access object. That's what DAO stands for. And inside of here, let's create some movies. I'm just going to copy this one over because that one's really tedious to type. And let's have some functionality in here that lets us update things. So I'm going to say fun update movie, which is going to be a movie. And inside of here, I will say movies sub movie.id equals movie. So when somebody says, give me a list of all the movies, they can actually come back and say update. Actually make this, I just want the list really. So let's do a val movies equals movies. Actually make this a var because he's going to change. Values. Actually, I'm going to do it this way. Let's do a list movie. And then we'll say get equals, grab those values, starting with an empty list. And what is he unhappy about here? Found mutable collection. Oh, to list. There we go. Okay, and then anytime we update, we're going to update the movie in place. So this guy has a no set method providing array access. Oh, because I changed my name there. There we go. And then what we're going to do is, let's do this with the observer pattern. Let's have a, I don't want to do this. So we'll say var, actually we'll put it as a val unchanged, something like this. So we'll just have a callback function that can tell us that stuff has changed. And so in here, I'm going to say unchanged. So we'll explicitly call whoever is listening to us. Okay, so that's our update. Let's see, anything else I wanted to do. So I'm exposing my movies. I'm giving an update. That should work pretty well there. And let's create a view model. This is going to be a class that the view, oh yes, question. Oh no, it actually, they're truly being run parallel. But the coroutine managers and dispatchers choose how many to run at a time. So you can specify how many you want to run, and the coroutine manager actually takes care of running multiple of those very, very quickly. The big difference that you get is that the dispatchers manage a pool of threads. And let's see, did I skip over what I wanted to say on there? I did skip over all my definitions. Let me go back to, let's create a new guy in here. Put him at the top here. New file, definitions.txt. And let's actually talk about what each of these pieces are to start with. That might actually help us. So I'm going to just copy that stuff. Okay, so we're going to start, the first concept here is something called a coroutine context. And this is an object that has a, did you have another question or hand still up? Oh, no worries. So we're going to start with this coroutine context, which is basically a set of elements describing an environment in which coroutine is run. The biggest thing, the two that are most important here, is something called a job, and that represents what's running for the coroutine, and a dispatcher, which manages the set of threads used to run that coroutine. So you can think of a job as a cancelable thing. So this is our coroutine that's actually running. They can have children. And this is another super powerful thing with coroutines, is that they can be structured. They call this structured concurrency. So you have a parent job, which can have child jobs. And if you cancel the parent job, all the child jobs are canceled automatically. You can also have it so that if any of the child jobs fail, the parent is canceled as well. It just depends on how you configure that parent. The dispatcher is going to manage the threads that are actually running the coroutine. And as you get each of those chunks in the coroutine being run, they get sent to the dispatcher to say, hey, I'm expecting you to run this. Please run this when you get the chance. And the dispatcher might only have a single thread. He might have a whole bunch of threads, or he might have somewhere in between. There's three basic dispatchers defined to start with. One is called main, and this is typically used if you're running on a user interface. So if you're going to be using Java with Swing, for example, you could use the main for that. If you're going to be using Android, you could use the main for the user interface there. If you're using those mains, you're going to have to pull in a different library that specifies how to use main for a desktop application for running Swing, or how to use main for Android application. I/O is used for any type of really I/O intensive blocking calls. This usually is file calls or network I/O. Those ones can be really super expensive, and you want to make sure that the threads are dedicated to doing that so it can reuse them appropriately. Dispatchers.default is really just kind of general use compute tasks. So anything that's actually just going to be doing some work that's not IO bound and not UE bound, that would go into IO default is a good choice there. Or if you wanted to say have a custom thread pool where maybe you define 4 threads that it's going to choose from, and you're dedicating those threads to that thread pool, you can create a custom dispatcher that uses those threads. So that's basically the idea of what a coroutine context is. It keeps track of these two pieces here. To start your coroutines, you can either do launch or async, as we've seen. So launch is if you don't want any result, you just want to perform some processing, and then the coroutine stops at the end of that lambda. Async allows you to do an await to get the result. And then await can be anywhere you want after you've defined the async to start it. Each of these can be passed a context. So just like this guy here, which includes a bunch of elements. You might say, I want to use a different dispatcher to run this coroutine that I'm launching. That's merged with whatever the existing context is. So when you call launch, he has a coroutine scope as the receiver. The coroutine scope is just a holder for the context. And he also has some convenience methods like cancel. They do this coroutine scope as kind of a handle so that you have a separate receiver type from the parameters that are being passed to launch an async. Those parameters are another context, which gets merged with the receiver, which is a coroutine scope. So he merges this context with the receiver to add different things or change things. So if you said launch dispatchers IO, it's going to take that dispatchers IO and merge it into whatever coroutine scope was running. So maybe the coroutine scope was running on the main dispatcher to start with. When you say launch dispatchers.io, it's going to take the IO dispatcher and use that instead of the main dispatcher for the body of that launch. Okay, so that's those guys. To create this coroutine scope, there's a couple things we can do. There's one called run blocking. And you can use this for unit tests is really the main place. You can use for command line apps, but you won't have cancellation control. So in general, you want to avoid this guy, and you want to create your own context to manage it so you can explicitly mention what's going on. Or if you're using a user interface, you'll use dispatchers.main inside your coroutine scope. Now to create the coroutine scope, the first thing you need to do is create a coroutine context. And one of the simplest ways to do that is something kind of like this. You can just say coroutine name my context. And this just creates a brand new coroutine context that just has that name attached to it. But typically, you're also going to want to add in some dispatcher. Like maybe the default dispatcher is one you want to use for anything that's launched, and then you can explicitly change the context to IO later, or maybe you start with IO and just use that for everything. We can add to this. Oh, I just actually did the same thing there. You can add to it to be more specific on when you use that context to launch a coroutine, under what conditions is it launched. So in this case, he'll have that name and he'll have the default dispatcher. Now we can create a scope just by saying scope equals coroutine scope, passing in the context, because he's just going to be a handle to him. Then to start the coroutines themselves, you'll just call scope.launch or scope.async. If you're already inside of a suspend function, you can just call launch or async. The other one is run blocking. Yeah, I repeated that, didn't I? So I'll just come back there. There we go. So run blocking again. try not to use that. And I should also say, do not use global scope. Tempting, but don't have proper cancellation and error handling. So this is something that they defined early on. They were thinking that could actually be the way to jump into something, but don't use it. It really is not an effective thing to do. You can create your own coroutine, or you can use ones that already exist. In Android, for example, there's one automatically defined for view models. You could use that. There's also ones defined automatically in the user interface layer if you're using Compose. Okay. Inside of your coroutines, if you say delay and then a number versus sleep, which is the thread version of it, this will suspend your coroutine for that many milliseconds. And it's super efficient. This is non-blocking. So your coroutine can suspend, somebody else can use the processor. If, on the other hand, you were using threads and you said sleep, that thread has to sit there and wait for that entire sleep. So it blocks anybody else from being able to use that thread, and you're wasting a resource at that point. You can also call with context, passing a lambda, which again he suspends, but he's going to change to that context when running the lambda that you're passing in there. Okay. Now, just like we were talking about cooperative processing in general, cancellation is cooperative. If you call scope.cancel to cancel something, you actually have to do something to make that cancel happen. Cancel is done using exceptions. They throw something called a cancellation exception. And for you, anytime you call one of the standard suspend functions, like with context, yield, delay, or something like that, these ones will automatically check, have I been canceled? If so, throw an exception. If I don't call one of those, I should call ensure active once in a while. So if I go back to this guy, inside of here, let's say there was a whole bunch of stuff that I was doing to do the processing. And maybe I'm not calling any suspend functions inside there. So if I was doing heavy processing, be sure to call without calling suspend functions. Be sure to call ensure active. Something kind of like that. Or you could check if is active, do something. That's another option there. But what ensure active does, if we take a look at him, is he just says, if I'm not active, throw the cancellation exception. That's it. That's really all he does. And so if you're doing a lot of heavy processing, find some spots to throw an ensure active call in. And then what that'll do for you is that will take care of your responsibility to deal with cancellation. Otherwise, you might not actually get canceled. It'll still keep going up until one of those suspend functions is called. Okay, any questions on that? Yes. These guys here? Oh, yes. Yeah. Okay. Sure. Yeah. So just in our normal Kotlin syntax here, without the coroutine stuff, here's like an equivalent of this. I'll just call it fetch actors X. Here's an equivalent of this function running synchronously. So what I'm defining here is a function that takes no arguments and returns a list of actors. And then remember the equals is used here if we have a single expression that this function is performing. Now, if we don't have a single expression, so that's 1, Let's call that x1 and x2. If we want to have a full-on open curly inside there, we have to say return list of to get there. This one down here, when we go to the coroutines version, we're saying our return type is still list actor. Our single expression is this with context block. So with context is a function that has a lambda, which is the actual stuff that's run on this dispatcher. That lambda, whatever the last expression is inside that lambda, is the result that's returned, that's returned from with context. So you notice here this little caret with context note that the editor is showing you. This is saying that this is the return value being returned from with context, which, because we have the equals here, is being used as the single expression that we're setting up for this function. Does that make some sense? Cool, no problem at all. You get used to the syntax after a little while. This is a very, very common way to specify a suspend function. This sets up the suspend function to be main safe. And what this means is that if you run this suspend function in the main dispatcher, it will automatically switch to a different dispatcher that it feels is necessary. If we just had this be equals list of, or had a open curly and then return list of inside here, it would run on the dispatcher that the caller used. So this is saying I don't trust my caller. I want to make sure that I'm going to the dispatcher that I think is appropriate. And the caller can be on whatever dispatcher they want. This will switch over. Okay, so that's about all of the definitions. Did those definitions help a little bit? Mm-hmm. I'm sorry, one more time on the last part. Yes. So as long as you haven't done a launch or an async, whatever is inside the suspend functions. So like here, because I'm not doing a launch, everything inside of the suspend function is synchronous. If I call these from different, like in this case, you see I have the launch here. I'm starting a new coroutine. And so this fetch act, well, inside the coroutine, I'm actually launching another coroutine with the async. This guy is going to be run in this coroutine here. In this case, when I say for each actor, because I'm calling launch, each of these fetch movies for actor is going to be a separate coroutine that was created. And so they're all going to be, for all these actors, they're going to be running concurrently. Now, this guy here, because he has that equals with context, he's going to make sure that this runs on dispatchers.io. If I wanted to be explicit here, I could have put dispatchers.io here as well. And this says everything that's run inside the coroutine started by this async is on dispatchers.io unless we switch it to a different dispatcher. So if I had other code inside of here, like setting some variables, processing data, whatever, that code would be running on whatever this dispatcher is. Does that make sense? Well, if they're not nested, so in this case, let's take a look at what this guy does. So for each of these actors, notice that these launches aren't nested. Whoops. These launches aren't nested inside each other. They're running as siblings. So this guy here is a child coroutine of this one up here. So we're starting the first top level coroutine here. These guys are all separate coroutines as children of him, and these guys all run in parallel. Now, one other little note here is if I had something here, which is outside of this launch, what's going to happen is for each actor, we're going to launch a coroutine, And then once that coroutine's been launched, we're going to do this stuff in parallel with that coroutine that we just launched. Does that make sense? Cool, cool. Mm-hmm. Okay. Now, I should note that the actual which order things are running and startup time may affect if this is actually running concurrently or not. So in this particular case, if this thing down here was super fast, it might actually be done before this launch has actually kicked off. So this is saying start up a coroutine. So that's going to actually be doing work to start it up. If this is fast enough, maybe this coroutine wasn't actually started yet. And so that's one of those things you have to be careful of wraith conditions and things like that as well. Okay, so we had some definitions, and so now we were setting up our DAO. Let's come back to here. So in our view model, this is going to be the thing that the user interface looks at to get its data. So he's going to take advantage of the movie DAO to do something. So inside this view model, I'm going to also have unchanged. So the user interface can know when it needs to refresh. And then inside of here, let me put a little note at the top here. Do just a little bit more, then we'll take a break. So in the view model, I'm going to create an instance of this movie DAO. So we'll say DAO equals movie DAO. And he's going to be passing in that onChanged, which is just going to in turn call this onChanged. And just as a note, I could also have written this as that. And this would just forward it through using that actual onChanged as the Lambda being passed to movie DAO. This only use if you don't need to do anything extra in the view model. Use this approach if you need to do something in addition to notifying the creator, the view model creator. So we'll call onChanged there. Just going to comment him out for the moment. So this is going to allow us to, anytime the movie DAO sees a change, he notifies us. We're going to notify whoever created the view model. Okay, so, whoops, why is that? That was odd. Okay, let me find where I was going with this. So let's have a var. Oh, actually, I wanted to also, by adding private set here, that means that only the movie DAO can actually change that movie list. Somebody else can't change from the outside. So this guy is going to have, what did I want to do in here? Movies. It's going to be a list of movie. And we'll just have that be an empty list to start with. And we'll do a private set again so that nobody on the outside can tweak that. And let's have a var selected movie, which is going to be a movie. And we'll just define him as null. Now let me talk about this null for a second here, and then we'll take a break. Think about how this might actually have to be updated. Let me find my code that I wanted here. Let's say that we're inside the user interface. And inside here, let's say that we had the view model passed in. And then inside here, let's say that we wanted to print out something about that. Let's say we want to display the selected movie. If we're doing that, we might need to get some text here. Let's say title to display. And say view model dot selected movie dot title. And obviously that's not going to work because that is nullable. And so we have to use the null safe to reference him. But if I do this with the null safe operator and there is no selected movie, we get a null. And we don't want to display a null. So obviously Elvis comes into play like that. And this allows us to give a default thing to display when there's no selected movie. That's one approach to do this. But what if we applied the null object pattern here? What we can do is say, I'm going to say private val null movie. We're going to define a quote unquote null movie as a movie with dummy data, kind of like that. This is the null object pattern. Oops. And this allows you to use something that's not actually null, but has dummy data. So if you're in an application where dummy data makes sense, this isn't going to be valid for everything. Sometimes you really need to know, is it set or not? In this case, really all we're doing is we're always going to be displaying something. But we have to do a little bit of extra logic here to actually make this work. If we use a null object pattern, because we're always displaying an empty string if there's no valid data, we can do something like val selected movie equals null movie as our default. And now selected movie is no longer nullable, which means down here, you'll see that he's saying, hey, you don't need that anymore. We can do something kind of like that. And notice how Elvis is now gray. I can get rid of him. So in this particular example, if we want to always display dummy data and we don't care about other data that's in there, we have the title to display and the year to display. Maybe we want to convert it to a string. This can be much, much more friendly. Consider the null object pattern. If you end up seeing a whole lot of question mark dots and Elvises all over the place, this can actually help. Oops. Something like that. Does that make sense? I always like to bring that up in cases like this. It doesn't work everywhere, but it's one of those things that, the less nulls you have around, the easier it is to deal with your application. And fortunately, Kotlin handles nulls very, very well, so that if you do have something that's nullable, it's going to keep poking you to say, hey, you're not considering null here. In some cases, that's going to be a warning. In some cases, it's going to be an error, like with the question mark dot. Any questions on that? Okay, so it's 8:46. Let's say 8:56 we'll start back up again. Okay, any questions before we move on? Okay, so I just made a couple tweaks here. I made selected movie var so that we can actually change it. Notice how selected movie is in the view model here. It's not in the data layer. That totally depends on what you're defining for your architecture. In this case, I'm considering it to be part of the user interface, and it's not stored data in the data layer. Okay, so we've got data like that. Let's create our user interface in here. Let's say What do I want to have it be in here? Oops. Let's create a panel to hold the movie buttons. So I'm going to have, basically this is going to be a little display that's going to show the names of the movies. When you click on them, you're going to see the details in the center. So movie buttons is going to be a JPanel, and it's going to be a grid layout with one row, actually 0 rows and 1 column. When you're specifying the grid layout in Java, if you say 0 for one, it just ignores that and then calculates it based on the other one. And then maybe we'll just give 10 pixels in between each. So we have him, and I don't think I need anything else for him to start with. And then val movie details is going to be a JLabel with nothing to start with. And then let's define a JFrame. And we'll put some details in there. I'm going to say his layout is going to be a border layout. And we're going to say add border layout.west, our movie buttons, and center our movie details. And then our default close operation, and our size, let's say 600 by 400. Whoops. Size equals dimension, blah, blah, blah. That's good. And then is visible equals true. So what we're going to need to do inside our main here is populate the movie buttons with the data from the view model. So let's get our view model. And he's going to need that lambda that says what to do whenever anything changes. So one thing I'd like to also do is call onChanged as soon as this starts. So let's have our init. We'll call onChanged. I'm actually going to move that down. Actually, I have my DAO. And when my DAO changes, it's going to call onChanged. So actually, let's put that in the init for the DAO. Make sure we call it. Be careful on things like this. If you just say onChanged, you're just referencing that variable. You're not actually calling the function. So I'm just going to put the parens there to make sure we call the function. And then that should, so you have onChanged. So this is going to tell the caller that it changed, but I also need to set movies when the DAO changes. So I'm going to say movies equals DAO dot. Didn't I have it called movies? Yeah. Oh, recursion fun. Ooh. So I'm going to need to say private fun onChanged. We'll say on DAO changed. And we will just put those there. There we go. And then this one we're going to pass in on DAO changed. I think that'll work. Well, that no longer applies now. Get rid of that. Okay, so we have our DAO. This should be private. There. So when the DAO is created, it's going to call our onDAO changed to set movies. I'm just thinking initializer order here. I'm not really liking this. The problem that I have here is that I set it up so the movie DAO, when he's initialized, he's going to call whatever the function is. which is going to end up calling this function before these other variables have been set up. Now I could, well, the bigger problem is that he's calling on DAO changed before the view model instance has been finished setting up. So inside of here, this is in an incompatible state. So this is actually not a good thing. I'm going to do that, and we will just be explicit on this. So we'll still call this on DAO change when he changes. We're just going to only call that when the model data changes. Sorry, when the DAO data changes. So to fix this, when do I want to call? So I've got the movies set up here. That's the empty list. So what I probably should do is just initialize this to, oh, wait a second. There, that's what I want, because I'm not actually setting that, am I? Yeah, I'm always getting that. Okay, so that's good. So now down in here, I can say this is DAO.movies, and that's going to be a val. Oh, I'm going to make that be a get. There we are. And so now we don't need to set that. We can just change this one back like I had it. Okay, and that should be used from the UE. We should be good there. Good. So now down here, we have our view model. Whenever something changes, I need to update stuff on the screen here. So that's going to be setting up some buttons there. So I'm going to say, let's put him down there, just so I have the definition set up. So we'll say movie buttons. Let's first of all remove any buttons that were already there. Now, normally I would use a dynamic list here as opposed to, and I can't remember what the dynamic list in Swing is. Oh, a JList. Duh. Normally I'd use a JList for this, but I don't want to go into the detail. I'm just going to keep it really simple. I'm going to use this panel, remove all the buttons, and then add in the buttons for each movie. So I'm going to say remove all. And then what I'm going to need to do at the end here is do a revalidate so that the UE will actually update itself. That's something I forgot when I was testing this out earlier, and it looked like the UE froze, but it was just a matter of the old buttons were still there and they just didn't do anything. So we're going to remove all the buttons, and then we're going to take a look at all the movies and add them in there. So we will say view model. I'm doing that recursive thing again here. Let's create a function. I don't know if I mentioned it, but you can have nested functions in Kotlin, which is actually pretty nice. Update movies. Oh. Ever have a feeling it's going to be one of those days? So how do I want to do that? How do I get around this recursive issue? So this is going to need to, oh, so I can do that. And I think if I use the function reference, it'll be okay. Nope. This will be easier the other way. I'm going to do it every day. So, I wish I had done this example earlier. I'm going to convert this to use coroutines and flows in a little bit, which will make this a non-issue. But what I can do here is, instead of defining the onChanged inside the constructor parameter, I can just define it as a separate property and set it afterwards, and that'll fix it. Okay, good. So what I'm going to do is I'm going to do something similar to the null object here. Instead of having this lambda be defined as nullable, I'm actually going to define it as an empty lambda. That way, if it gets called before it's set, it just won't do anything. So now we can set that down here. We'll set him up, create that view model. We define our update movies, and then I can just say view model. Oh, this is a problem because these are nested functions in main. If I had these defined in an object, that circular thing wouldn't have been a problem. So I'll say view model dot onChanged equals update movies. Oops, colon update movies. There we go. There, and that's better. Whew. Okay, now I'm feeling better. So we have our view model set up. We're going to have our update movies so that anytime the view model changes, we'll get the data, update that stuff on the screen. And then what we need to do is explicitly call this to fill in the details. So we'll start off with an update movies call here just to do the first setup. And this should give us some buttons. Actually, we didn't put any buttons in there, did we? So update movies. Oh, well, that's bad. Let's go ahead and add in the appropriate buttons. So we'll say movies.forEach, and then we'll create some JButtons. So we'll say movie buttons.add JButton, passing in $movie.title. Actually, let me do this. I want 2 lines. So I'm going to say, give me a break, and then $movie.year. We'll see why I do that in a minute. So we got that. That's going to add that button. Let's do an apply on him so that I can add the action listener. And when this button is pressed, I want to update the button in the view model. Now that I have that update defined, so update up here works. Let's create a pass-through up in here. Fun update movie, and then we'll say DAO.update movie, something like that. Okay. So in our add action listener, we're going to say view model.update. And what I'm going to do is I'm just going to take the movie that I'm dealing with here, and I'm going to add 1 to its year. So we'll say movie.copy year equals movie.year plus 1. So we're using this copy function that was defined because it's a data class. Okay, so this update will end up getting passed through to the DAO. The DAO will then call onChanged, and the data will come back down just to poke us to say you need to fetch it again. Then we will refetch it, updating all the buttons on the screen. And I think that should be good. Oh, I want to do the select as well. So we'll say view model dot selected movie equals movie. And we're going to update the contents for that movie there. So we'll say movie details dot text equals view model selected movie to string. We'll just keep it nice and simple. Okay, let's see how close we are. So we have a little user interface with the Terminator, Transporter, and Into the Spider-Verse. When I click on each of these, it updates that section in the middle. Hey, yeah, that did exactly what I wanted. And notice also when I click on it, it's updating the year each time. That's sending it off to the DAO to update the data, which tells us the data has changed, and then we refetch the data. So there's a little more going on here that we might want. That extra call to say the data has changed kind of separates us from the data. The unchanged, it's up to us to understand the data and know how to fetch the changed data. So we're going to change things up here a little bit and take advantage of coroutines with something called a flow. And what a flow is it is an object that will emit data that can be collected inside a coroutine. The flow could be a fixed set of data. So you could take a list and create a flow out of it. And then the consumer starts up a coroutine, collects the flow, gets each piece of data one at a time. Or what we're going to do here is we're going to use something called a state flow. And a state flow lets you drop data in. It's kind of like a bucket. And then the user interface will say, I'm going to collect from that bucket. Anytime the value in the bucket changes, that collect gets triggered to do something. So let's take a look at all of this and put it into here. And this is number 6, right? Good, okay. And let's tweak things a little bit here. So what we want to do is right now, we've got just this list of movies that we have to pull. So the view model pulls that list of movies. He basically just has that get that passes it through. The user interface pulls it. What we want to do instead is flow that data down. So we're going to be setting this up so that from the user interface standpoint, the user interface makes requests to the view model, which makes requests to the DAO to do an update. The DAO then says, oh, I'm going to take the updated data, dump it in a flow that's passed through the view model down to the UI, and the UI can just say, let me grab the data from the flow and display it. So it's a little bit simpler way to approach things here. So I'm going to say this is going to be a flow-based approach. So we start off at the movie DAO level. Instead of having movies exposed this way, we want to expose them as a mutable state flow. Think of this as a bucket. You drop a value in, and then somebody can collect that value. Drop another value in, somebody collects the next value. So we'll start off in here with a movies flow, which is going to be a mutable state flow. Whoops. Might help if I said val there. And this is going to be passed in the initial list of movies. We can then update this by saying moviesflow.value equals something, and then that changes the value and it can be emitted. But I don't want the user interface to be able to update this. If I came in here and made this public, the user interface could then say moviesflow.value equals something. I only want my data to flow from the movie DAO to the view to the user interface. So I'm going to make that private, and then I'm going to expose it as a flow that you can't write to. So I'm going to say val moviesflow. Note the underscore in the first one is going to be a flow list movie equals underscore movies flow. And oh, I didn't do the values dot to list. So what I'm doing is I'm taking the values, just these movies here, and then getting all those values and converting it into a list. So that gets me a fixed copy at this point in time of what that map looks like. When we do our updates, we'll do that same type of setup there. By exposing this with type flow, the caller can't say movies flow dot value equals something. All they can do is collect from it. Because if we look at this flow interface, all he has is this collect function. We're going to call this from a coroutine. You notice that we have to, whoops, my monitor wants to turn off. That was weird. because this is a suspend function, you know you have to call it from a coroutine. So we're going to start a coroutine, and the coroutine is going to call collect. So it's just calling a function that's going to give us these values to collect. So we have that. We no longer need this guy, no longer want that guy, and we're no longer going to have the unchanged, which will help get us out of that whole cyclic mess that we had. But what we need to do is update that movies flow here. So we've changed the movie in the map. Now we need to say movies flow dot value equals movies dot values to list, something like that. Now normally we don't use an underscore here. Usually you just reserve the underscore if you have pairs of properties like this where one is derived just to expose the other one as a new type, usually a more limited type. So now our movie DAO's gotten a little bit simpler here. We don't have that observer. It's not responsible for just notifying somebody who then has to understand what data to pull. Anybody who is collecting movies flow will automatically get this new value when the data is updated. So now down in here in the view model, we no longer have this unchanged mess, but we do need to collect it. That collection has to happen inside a coroutine, so we need to do that kind of similar setup that we did before. I'm going to come up here, and I'm going to say val coroutine context equals coroutine name. I'm going to say view model, and let's say this is going to happen on dispatchers.default, because we're going to be doing this for collection, so it's not an IO based thing. We're just going to be collecting it in a background thread. Sorry, background coroutine. And then we can say val, view model scope equals coroutine scope around the coroutine context. So that gives us a scope where we can start coroutines. Okay. Yeah, so down in the update here, we're going to use this guy to call the update so that he's happening in a coroutine. So if we go up to the DAO, this guy here is going to be doing some kind of IO, possibly writing to a database. So we want to make him a suspend function. And then when we call him down here, say view model scope dot launch to do the update. Boom. So that's going to kick off a background task, a background coroutine to update the database there. And then we need to fix up our movies here. Now our movies is just going to be, and let's change this to say movies flow, is just going to be DAO.moviesFlow. So we're just going to expose that through so the user interface can get to it. And I think let's actually have a select movie, and he's just going to say, we want to do the same kind of thing. We want to set up a flow for the selected movie. So we'll do a private val selected movie flow. He is going to be a mutable state flow of type movie. We're going to pass in the null movie for him. Oops. There we go. And then we're going to expose him, again, same type of pattern that we used before. We're going to expose him as selected movie flow, just exposing him as a flow, which is going to be giving us a movie to look at, equals selected movie flow. There we go. So now he can be exposed there. We don't need this guy anymore. And this one's going to say selected movie flow dot value equals whatever the movie is that was passed in. Okay. And we don't need this guy. Get rid of him. Okay, so our view models is got these guys just so we can run the update inside the view model scope. And we've got the selected movie flow that we're passing through. So we have movies flow that can be collected and selected movie flow that can be collected. So now down in, I'm going to get this out of here because we don't need him anymore. So now down in our main here, we're not going to have this update movies function. We're going to be a little bit more direct on things here. What we're going to want to do is, first of all, get those scopes. I'm going to just copy these because it's going to be similar. We're going to need to start a coroutine. So I'm going to call this my main. And I'm going to, again, use dispatcher's default for that because this is for processing stuff. It's not actually doing any I/O. And then inside here, I'm going to say scope.launch. Oops, not view model scope. I'm just going to call this coroutine scope. Something like that, just so we can do our collect. So I'm going to go to my view model, grab the movies flow, and say collect. And then here's the code that runs it. Now notice what's happening here is this is just a function call to grab stuff and process it from the movies flow, running in this coroutine. We're not running in a coroutine on the we're not running in a coroutine inside the view model or inside the DAO. It's this coroutine that we're running the actual collection in. So now for this collection, this is where we're going to do our updating. So I'm going to take this guts here, move it up into there. And so let's see. Now this is returning the movies. So anytime we collect, it's going to call this lambda for each value that it sees. So we get rid of this view model.movies, do that. We're going to have to update our selected movie when the button is pressed. So this guy is going to say view model.select, passing in the movie. And then this will actually happen based on the selected movie changed. So if I come into here and again say, let's start another coroutine so that we can say view model dot selected movie flow dot collect, and we'll move this guy down. Now this I really like because now instead of, let's actually add him in here and fix this error first. Instead of tying together the setting of this guy up inside here, we now are setting it up so that we have two separate pieces of data that we're looking at from the view model, the list of movies and the selected movie flow. This guy now, instead of explicitly setting the selected movie, he's asking the view model to do that for him, which will then force the collect here to see a new value because we're changing the value of him. Okay, so this goes away, that goes, and this actually we're not going to need anymore as well because the collect is going to pick up that first value that was set inside there. And let's see, is that going to be about it? I think that might be it. Let's try running this. Make sure I run the right one. Okay, so we'll notice that here's that null movie being displayed where he has the blank title and ID and -1. Here's our movies. They came from that flow. And then when I click here, he updates and updates over here automatically. All right, come here, I can do that update. And so it's behaving exactly like we want it to. Now notice though, this is 1990 and this is 91. That's because when we click on that guy, there he is, we're updating the movie and we're selecting the movie object that's the original actual movie. So we're seeing the older data, not the updated data. And we could play around with this by putting the selection inside the DAO if we wanted to. And that way the DAO could say, hey, when the movie's updated, let me also update the selection. if the selection is one of the movies that's updated. And then that would take care of it, so we could have the same value there. Otherwise, the other thing we could do is explicitly make a value that keeps track of this copy of the movie, and then use that value here. I'm not as keen on that because now the user interface is having a little bit more smarts about which movie is actually being used where. So I'm not quite sure I like that approach. Okay, so what this has done for us is now separate it out, collect the data, and all I care about here is the data. I don't care about an event telling me things have changed. I'm just saying I'm interested in the movie's data. Let me take a look at the current value and set up based on it. I'm interested in the selected movie. Let me take a look at the current value and set it up. I no longer have to have knowledge about what to do on change and know which of these guys might have changed. And in this case, the on changed, this guy might have changed some other way, and with the on change we had before, it wouldn't have actually updated. Okay, any questions on that? So what we have is this is a coroutine running. This is another coroutine running here. And the main is running as well. So launch those coroutines. We set up our user interface, which is on that main thread. This is the user interface thread. And what's going to happen in this application, the way that Java does this, is when this main is running, it's going to get down to the end here, and the main is done. It's set up the UE, it's set up those two coroutines, it's done. But what Java does is anytime there's a thread running that's not a daemon thread, so whenever a non-daemon thread, whenever I should say any non-daemon thread is running in the Java virtual machine, the process is alive. If only daemon threads are left, the process is killed by the VM, just like that. So let's take a look at if I run this and then hit X here, that ended up killing the application because the thread here for this is the main thread and he's a non-daemon thread. The threads that it's creating for the default are set up as daemon threads, so they're not going to block the virtual machine from canceling itself, from closing. Does that make sense? But just because we got to the end of the main, we didn't end the application. We spun up the daemon thread. We spun up threads for these coroutines, which we spun up the non-daemon thread. We spun up the coroutines, which are daemon threads, and then we're in great shape. Does that make some sense? Now, if we were doing this on some other platform, like let's say we're doing this on Android, one of the things you have to be really careful about are things like this. On Android, the only thing that can update the user interface is the user interface thread. If I try doing this, note that this is actually running in whatever thread this coroutine scope was launched in. And that coroutine scope is using the default dispatcher, so it's not the main thread. So on Android, this would blow up. They would throw an exception saying you can't modify the UE from the non-UE thread. There are some ways around that, but don't do it. That can cause all sorts of grief. So what we would need to do that update is to switch over to the main thread. So you would need something like a with context dispatchers.main. Something kind of like that. Now this isn't a problem for using Swing this way. The update for the text here can happen on a non-UE thread, and then the user interface thread is told to do the actual refresh of the user interface. But on other platforms like Android, Make next line. You may need to do updates on the UE thread. And so this becomes really simple to do. This with context you put in there, it still ends up looking like this is just this whole coroutine here. It looks like it's just a single function. But what's happening is when we launch this, this starts on the IO dispatch, or sorry, the default dispatcher. Then when the collect is running, it's running on that default dispatcher. When we get to this point, we switch over to the main dispatcher, perform this code, and then we come back out, we're back on the default dispatcher again. So it's really switching over between different threads to run this. I should also note that if you have multiple, let's see, what would be, well, in this case, let's say that we had do something there and a do something here. Not guaranteed to run on the same thread as that. Let's say call that, and we'll say call this that runs on a thread managed by the dispatchers.default. And let's do this. Let's say call YYY. I'm just going to add this in like this. So what's happening here, dispatchers.default is managing multiple threads. There's no guarantee that this call and this call are going to run on the same thread. So up here, it picks one of his threads to run it. Down here, he picks one of his threads to run it. What's really important here, don't use thread locals to hold data. Let's say here, it's a Java thing. If you're not familiar with thread locals, all the better. Thread locals were something you could use to say, for a given thread, here's some data I'm temporarily holding on to. So you could use that while something is running and make sure that the place that, or the thread that it's running on, maybe you have the same runnable running on multiple threads. You can use thread locals to hold some data for the execution on that thread of whatever you need to call. So if you were calling a bunch of functions, all of those functions could get at this thread local. Think of it as kind of like a global variable that's specific to a given thread. And you could have multiple values. If you're not familiar with it, don't worry about it. It's something that it's a little iffy to use in Java. I've used it a few times. There are some good reasons for it, but don't use it from coroutines. Because if you use it from coroutines, you can get some really bad results because of the dispatcher using different threads. Now the dispatcher may use the same thread if it wants to, but it's not deterministic from your point of view. So don't rely on that. But then on that. That makes sense? Any questions there? Okay, well, that pretty much wraps up what I wanted to talk about for coroutines. Are there any questions in general? Cool. Okay. I will post the assignment in a little bit, as well as the video from the class. If you have any questions, post on the forum, come to office hours, send me an email, any of all that. Have a great night.